This is lesson 4. We're solving equations using addition and subtraction and multiplication and division. So when we're trying to solve these equations, we want to think of ourselves as being on a balance beam or a scale. So what I mean by that is, if we take a look at these scales, we've got some value x here on the left side, and it's with 3 little units, widgets or whatever, and that equals 5 widgets. So then what we'd do is we'd say, okay, well, we've got 5 widgets on one side and 3 widgets with our variable x. We're going to say, well, let's get rid of these 3 widgets that are with our variable x, and if we keep our balance or our scale in balance, that if we take away 3 widgets from our left side, we need to take away 3 widgets from our right side to keep that balance or that scale in balance. And so then we can see that our scale, or this x widget, is worth 2 of the red widgets. Now, what's a widget? It just means anything. It's just whatever these little blocks are called. Our first example, solving this equation, so we've got some letter y minus 7 equals negative 2. And the question we always want to ask ourselves is, what is happening to the variable? So what is happening to this variable here? The variable is being subtracted by 7, and what we want to do is what's called inverse operations. So an inverse operation, what's the inverse of subtracting? Well, that would be adding. So if it says subtracting 7, y minus 7, we're going to add 7. We're going to add 7. What I do to one side, I need to do to the other side to keep my scale in balance, to keep my equation in balance. So negative 7 plus 7 makes 0. That simplifies out, or they cancel each other out to make 0. And so we're just left with y on our left side. That's what we want to have, is just solving this for y. And negative 2 plus 7 is 5. Our next example, what's happening to our variable? It's being multiplied by 7. So what's the inverse of multiplying? That would be dividing. So I put a little fraction bar and I say I'm dividing by 7. What I do to one side, I have to do to the other side to keep the scale in balance. 7n divided by 7, well, those 7's simplify to 1, so I've got 1n. And negative 35 divided by 7 makes negative 5. Now we can always check ourselves. We can check ourselves by substituting in a negative 5 for n. So my equation is 7n equals negative 35. That's the great thing about equations. So I can say 7 times what number equals negative 35? Well, if I plugged in a negative 5, does 7 times negative 5 equal negative 35? Yes, it does. So we know that what we did was correct, and this is inverse operations. Our third example, right here we're multiplying negative 3/4 t, so negative 3/4 times some number equals 9. So what would undo multiplying? Well, dividing undoes multiplying, but division, if we remember, if I had some number like 5 divided by 3/4, right? Then remember that division is the same as multiplying by the reciprocal, right? So I'd say that that was 20 over 3. That's what 5 divided by 3/4 is 20 divided by 3. Or 3 goes into 20 6 times with how many left over? 2/3, with 2 left over, so it's 6 2/3. So, but the point I'm getting at is that what we would do, this is multiplying by negative 3/4, so what we would do to undo multiplying by negative 3/4 would be to multiply both sides by the reciprocal. So what's the reciprocal of negative 3/4? Well, the reciprocal of negative 3/4 would be negative 4 over 3. So we're going to multiply by times this by negative 4 over 3. What we do to one side, we have to do to the other side. So on my left side, two negatives, I know we're going to make a positive. My 4 simplify to 1, my 3 simplify to 1, and we're left with t. That's the whole idea. On my right side, well, I can simplify here first too. How many times does 3 go into 9? 3 goes into 9 3 times. 3 goes into 3 once. 3 times negative 4 is negative 12. It's negative 12 over 1, which is 12. Okay. Using the distributive property and then combining like terms. So I've got this equation y plus the quantity 5 times y plus 3 equals 30. Well, let's distribute first. So say 5 times y. Let's bring down this y first. 5 times y makes 5y. 5 times 3 makes 15. And that equals 33. And so now we're going to combine like terms. We've got a y and I've got 5y. Y and 5y makes 6y plus 15 equals 33. And now we ask ourselves, well, what's happening to our y? We can see that y is being multiplied by 6. The question, what is happening to the variable? What's happening to the letter? Always ask ourselves that. So it's being multiplied by 6 and it's being added by 15. And we want to work our way backwards through the order of operations when we're solving equations, and that's by using inverse operations. So we're adding 15 and we're multiplying by 6. So if I'm working my way backwards, I want to undo the addition and subtraction before I undo the multiplication and division. So I want to undo adding 15. Well, what's the inverse of adding 15? Subtracting 15. So I subtract 15 from both sides, and we get 6y equals 33 minus 15. What is that? 18. And so now we say 6y equals 18. 6 times y, so what undoes that? Dividing by 6, y equals 3. If we want to, we can substitute this 3 in to our equation. If I had a 3 here and a 3 here, well, we'd need to follow order of operations. What's 3 plus 3? 6. 6 times 5 is 30, plus this 3 makes 33. So why don't you guys try and do these? This is a little bit different. My 12 is in front. This is the exact same problem as if it said 15 equals x plus 12. It's the same thing, so don't get confused here. So we're adding 12 and x together. So what undoes adding 12 and x together? Subtracting 12. So here I say x equals 3. We can plug in a 3 here. Does 12 plus 3 equal 15? Yes, it does. How about this one? We're adding negative 9 and n together to make negative 19. Well, what's the inverse of adding negative 9? Would be to add a positive 9. So n equals negative 19 plus 9. Well, I've got two different, I've got a negative and a positive. I know my answer is going to be the sign of the bigger number, so my answer is going to be negative. And we say 19 minus 9 is 10, so my answer is negative 10. Problem 3, negative 20 equals 5n. Well, what's happening to the n? It's being multiplied by 5 here. So we're going to divide both sides by 5. And when we divide by 5, we say these 5 simplify to 1, and we get n equals negative 4. A, what's happening to A right here? This one's a little bit tricky. A is being divided by 11. So what undoes division? Multiplication. So if we multiplied both sides by 11, write my 11 if you can see it right there, that's an 11. So we're going to say that simplifies out. That's what we wanted to do. So we're left with an A over on this side. And 11 times 15, well, we can do this in our head. What's 10 times 15? 10 times 15 is 150. And now we just have one more 15 to add in there. So 150 and 15 makes 165. Let's try some more. So what happened here? For B, we're multiplying by negative 7/4. So what undoes multiplying by negative 7/4? Dividing by negative 7/4. But division is the same as multiplying by the inverse. So this is going to be a little bit difficult to see, but try your best. So the inverse of negative 7/4, or sorry, the reciprocal of negative 7/4 is negative 4 over 7. So we're going to multiply both sides by negative 4 over 7. That simplifies out. That's the whole reason why we're doing it. So we're left with v on our left side, and now we can simplify if we can. Now I look at this first and I say, well, I've got a negative and a negative, so two negative factors. I know my answer is going to be positive, so I don't even worry about my sign now. My 7's simplify out, and my answer is 4 over 5. Problem 6, same type of problem. We're multiplying by 9/5. What's the opposite, or the inverse of multiplying? Is dividing, but dividing is the same as multiplying by the reciprocal. What's the reciprocal of 9/5? 5/9. What's the reciprocal of 9/5? 5/9. What I do to one side, I have to do to the other side. My left side will simplify out. It must. That's why we're doing it. So we get x by itself. My right side, my 5's will simplify, and we're left with 12 over 9. Now, we can simplify that further. What goes into both 12 and 9? 3 does, right? 3 goes into 9 3 times, and 3 goes into 12 4 times. So x equals 4/3. Problem 7. What's happening here? We're multiplying by negative 2. So we're gonna, the inverse of multiplication is division. So we're gonna divide by negative 2. Those two simplify out. That's why we're doing it. Two negatives make a positive, and so I'm just going to leave this as 5/2. You can simplify this further. 2 goes into 5 twice, and with 1 left over, so it's 2.5. But I like keeping it as an improper fraction, 5/2. What's happening to our p here? The p is being divided by 2. What undoes division? Multiplying. So we're going to multiply both sides by 2. That simplifies out. We're left with a p on our right side. 2 goes into 4. That becomes a 1. That becomes a 2, because 2 times 2 is 4. And so now I have 1 times 5 is 5. 1 times 2 is 2. So we get 5/2 here. And our homework is homework number 4.